today. Emissions from vehicles has become an absolutely critical subject around the world now. So we'll have a look at some of the problems there are and the problems that we're trying to solve. Not all emissions are the same. I'm sure you know this, but it is really worth just pointing this out at the beginning. It's the problem we're trying to solve for. Are we trying to solve for climate change? Climate change is all about CO2 and other greenhouse gases. So in terms of vehicle emissions, that really is down to how much fuel we burn. Every litre of diesel is about 2.65 kilograms of carbon dioxide that goes into the atmosphere. Now that is a fundamental of chemistry. There is nothing we can do about that. If we want to reduce the carbon footprint of our vehicles, what we need to do is burn less fuel. It really is as simple as that. So that direct correlation to fuel efficiency, and obviously with the Paris Accord, we are all trying to reduce CO2 and therefore climate change. So on the other side, we have air quality. And it comes to more curbside air quality, where we're looking at NOx and particulate matter. Remember, we've got the main four regulated emissions from diesel vehicles. It's NOx, particulate matter, carbon monoxide, and what's the fourth one? Hydrocarbons, that's it. Thank you, Paul. No, air quality is, it just goes to show how long it's been since we've done these things in person. So it's largely independent of fuel efficiency, and we know that many cities are in breach of the World Health Organization NOx limits, and we've all seen here in Hong Kong, in the summer, on the hot days, we can get quite uncomfortable at the curbside. So let's just define what a low emission vehicle is. And again, it really depends on what you're looking to, how you're looking to improve the vehicle and what aspects you're trying to address. There are a number of different approaches that are used in different places around the world. So let's take London as an example. That has been technology specific. London have mandated, for example, about 10, 15 years ago, they've started mandating hybrid vehicles, or in more recent times, electric vehicles. And they've been doing this for some time. So that's one method that a local authority can influence the vehicles by mandating a technology. However, probably a more practical route is making it performance specific. So in the UK, again, the Low Carbon Vehicle Partnership established, that's now ZEMO, but they've established performance definitions and testing protocols for low emission buses. So if we would take a bus in the UK, we would take it up to Millbrook, it would go on a standardized test cycle, and we would calculate the amount of CO2 per kilometer. And for that bus to qualify as a low emission bus, it would have to meet a certain formula based on the number of passengers it carries. And then compared with an equivalent, say, Euro 3 vehicle in the original case of the system, or in the case of later vehicles against Euro 5. So that's another method of specifying low emission vehicles. And then finally, what we're seeing now especially London, you're getting clean air zones. We've got the ultra low emission zone coming in London. And in that case, they're mandating a particular emission standard for vehicles. So in case of the ultra low emission zones in London and around the UK, that's Euro 6 in certain areas. And depending on what problem you're trying to solve will depend on which of these approaches gets you the very best results. Let's have a look at the evolution of diesel, because diesel has been around obviously a very long time, and there's been incremental changes as the Euro emissions have evolved since they came in 1993 with Euro 1. I think this graph on the left there is a really great example of how much better in terms of emission performance the diesel buses of today are Euro 6s, for example. So if we take 36 Euro 6 buses today, they would generate about the same amount of particulate matter as one pre-Euro bus that they replace. And I think that's a massive testimony to all the engine manufacturers in terms of delivering a better emission standards. I mean, I remember as a young boy going to the bus depots in London. When the buses started up in the morning at the run out, you'd have 50, 100 Gardner engine vehicles, and you couldn't see from one end of the depot to the other. And now, there's just no sign of a whiff of smoke, even on startup. I remember, you'd be black. just because you've been in the bus depot. And so it is transformational. And in terms of NOx, the same number represents 20. So let's have a look in Hong Kong. If you look in Hong Kong, where a bus that's being bought today is probably replacing a Euro 3 or a Euro 4. A Euro 3 vehicle, among 12 of those Euro 6 buses will generate the same amount of NOx as just one of the buses it's replacing. And in the case of particulate matter, that's 10. Now, I think that's a point that I think is missed by the authorities here in terms of the improvement of the general fleet. So I often put this in some congested cities that tailpipe emissions have sometimes been shown to be cleaner than the air in the environment. I'm not sure. I've heard that mentioned a lot. Whether it's actually true or not, I think it has. In certain circumstances, it is. But I think it's a really interesting stat, because the CRT on the vehicle is capable of cleaning the particulates that are in the ambient atmosphere. So let's have a look at Euro 7. So Euro 7 was announced in November last year. The Euro 7 regulations are intended to replace and simplify all the previous emission standards. So whereas at Euro 6 you've got different emission levels for cars and heavy-duty vehicles, at Euro 7 it's intended to harmonise that. And it broadens the range of driving conditions, because in the Euro 6 regulations, the short trips, for example, aren't covered, and they will be at Euro 7. Also, increased ambient temperature will be taken into account at Euro 7. There's tightened limits for pollutants. I think it's 35% reduction in NOx and 39% in particulate matter. So it's another step change from Euro 6. Also, in terms of tightening the emission for pollutants, what's happened there? Any advice? I'll keep going. So, as well as looking at emissions from the vehicles, it's also going to be regulating emissions from tires and brakes. Microplastics coming from the tires is considered a significant pollutant. Thank you very much. It's considered, and also particulate matter coming from brake systems will now be considered as part of the legislation as Euro 7. Nitrous oxide is added to the pollutant list. And now there's a longer period of compliance required as well. At Euro 6, vehicles needed to comply for 100,000 kilometers or 5 years. At Euro 7, it's going to be 200,000 kilometers or 10 years. So the vehicles have to be compliant for a significantly greater period of time. Euro 7 is also intended to support the deployment of EVs, and in that way it is expected to regulate on battery performance, so that a consumer is not at risk of being, say, lumbered with a vehicle that will require a battery change very early on in its life. And also there'll be some onboard vehicle monitoring in terms of onboard diagnostics. In terms of the technology required on board the vehicles, we do think at this stage it is likely that the vehicles will meet Euro 7 just using the SCR technology that is in use today. So let's have a quick look at emissions and pollutants. But I think I like this picture. This picture was taken in Scotland, showing one of our Enviro 500s there, and a representation of the number of passengers if they all traveled by car, and the number of passengers that you could get on one bus. And I think this speaks 1,000 words in how bus, just by taking so many vehicles off the streets, is at the first place a good news story in terms of congestion and emission. So we do need to promote as much as possible modal shift out of cars and into public transport. Just before we move on to other technologies and in-build, I think it's just worth mentioning what we could do with vehicles that are already in service today. So we're currently undertaking a retrofit trial with the EPD here to retrofit an enhanced SCRT system onto Euro 5 buses. So the SCRT, that's a selective catalytic reduction system fitted with a diesel particulate filter as well, a trap. And in that way, we can take about 80% of the 80% more NOx out of the system, and also over 80% more particulate matter as well. So it's early days. We fitted the first vehicles at the end of last year, but we've now got all 12 trial vehicles across 3 different vehicle types, across two different bus operators. And those vehicles have now saved, just those 12 vehicles have saved over 1,305 kilograms of NOx already. And I think that's quite an interesting stat when you look that we have built over 2,500, nearly 3,000 of these Euro 5 Enviro 500s over the last, since 2012. So there's scope there to improve the emission performance of vehicles that are already in service. That's got some exciting possibilities going forward. Need to check the time. It's okay. Right. So that's a little bit of background, and now let's look at new vehicles, what we can do with new vehicles, how we can design and develop new vehicles on that journey towards zero emissions. It's been a long journey. We've been at it for a very long time now, and there's a number of different stops on the way there. So we'll start with base diesel vehicles. We'll talk about efficient diesel vehicles. We'll look at some hybrid vehicles with mild hybrid systems, full hybrid systems, range extended hybrid systems, and then we'll talk about hydrogen vehicles and then the full electric products. So let's start with the efficient diesel. I've already said that diesels in buses is not a bad solution as it is. However, what we did discover in the UK is when the low carbon vehicle partnership put up a challenge to deliver low carbon emitting buses into the UK, we discovered you could do that by hybridization, but also using some clever tricks with the existing diesel vehicle, and we could get down to a bus that complied with the low carbon emitting bus standards. And that's important because in the UK, low carbon emitting buses at the time were being subsidized by the government to the tune of about 6 pence per kilometre. I think if you do about 80,000 kilometres a year, that equates to about 4,800, 4,600 pounds. So that's a really significant saving, especially if you consider that is going to be for the life of the vehicle. So you've almost paid for half of the vehicle over the course of its life just from this subsidy alone. So there was a big impetus to make the vehicles compliant to this. So how did we do it? So first of all, we looked at the cooling packs. So diesel engine vehicles traditionally have a mechanical or hydraulic drive to cool the vehicles. However, we introduced an electric cooling pack instead, and in doing so, that way we decoupled the fan speed from engine speed and was able to control that in a much better way, and therefore save us a reasonable amount of fuel as a result of it. From memory, it's about 4%, which is quite significant. We also introduced what we call the smart pack of accessories. So if you look at the standard ancillaries on a vehicle, you've got the air compressor, for example, you've got the alternator, and they would usually operate at all times according to the demand of the vehicle. However, what we did on this vehicle is tune these items such that they would prioritize their use when the vehicle was on overrun, and you weren't using it, say, as the vehicle was accelerating. In that way, you weren't adding to the load at times of peak demand, and in that way, we again save a little bit more fuel and therefore CO2. Also, we fitted stop-start. I think we've all got stop-start now in our cars pretty much as standard, and we're used to it. It's a little bit more of a challenge on a diesel bus where the starter motor has to work quite hard in a stop-start environment, but that has now been achieved, and that too makes a significant saving. And also, in common with all of Alexander Dennis projects, we've made them as light and optimized the structure as best as possible to reduce the mass. In the old days, we used to say about a mile per gallon per ton. If you take a ton out of the bus, you'd save about a mile per gallon. It's not quite as much as that, but it's a good sales point. So we saved about 18% of CO2 over an equivalent Euro 5 by implementing these options. Right, so that was diesel. Now let's talk a little bit about hybrid vehicles. Now this is obviously, as Alexander said, I introduced a lot of hybrid buses into the UK. Now that bus on the left there, I just put this up here because I think it's interesting to point out that electric drives are not necessarily new. That bus on the left is a 1924 Tilling-Stevens petrol electric. That bus has a 4-cylinder petrol engine, which is collected electrically only through to a generator, and then there's a motor attached to the rear axle, and it drives in as a petrol electric at all times, and it's a fantastic thing to drive. However, the driver was very significantly different in those days. The reason they used petrol electric was because the drivers were really struggling to cope with driving a bus which has got a clutch pedal, it's got a brake pedal, it's got a throttle pedal, you've got this lever that changes gears, you've got a horrible crash gearbox. They're a nightmare to drive. I've driven them for many years, and they are really quite taxing to drive. However, with a petrol electric transmission, you just have a regulator and a throttle and a brake pedal. So for a driver who previously had been used to pulling a rein to go left or a rein to go right with a horse-drawn vehicle, he's now able to drive a petrol bus without the complexities of a gearbox. So obviously times has changed, and we are now using hybrid and electric drives as per the right there with the KMV vehicle there we delivered in 2014 to this time to reduce CO2. So let's start with the basics. What is a hybrid bus? And really a hybrid bus is simply a vehicle that has more than one power supply. So in the case of the hybrid vehicle there, that's a bus that runs in Ireland. So what we have is, as well as the diesel engine, you've also got a battery pack as well. And because we've got that battery pack there, we no longer need to have an engine that will take the vehicle up the steepest hill at the hottest time of day with a full load of passengers. With a degraded cooling pack, for example, we can now size the engine more for average load. So here in Hong Kong, that Enviro 500 that you saw on the previous slide, that vehicle usually has got the Cummins ISL in it, which is an 8.9 litre, 320 brake horsepower engine, whereas in the hybrid variant, it's a 6.7 litre. In UK, we changed from the 6.7 litre Cummins B series down to the 4.5 litre 4-cylinder version of the same engine. So we can downsize the engine. And because that engine isn't working flat out as it's pulling away because it's being helped with by the electric system, we can also, or the battery supply rather, we can reduce fuel consumption. Because we're reducing fuel consumption, you're not seeing the transient demand on that engine, we're reducing emissions as well. And the best part about the hybrid is because it has got an electric driveline, as the vehicle slows down and the driver lifts his foot off the foot off the throttle, we can capture regenerative brake energy, store that on the onboard energy storage system as electricity, and then use that later in the drive cycle. And that's being able to capture that was the revolution in hybrid vehicle technology. And because we can decouple the engine now from the driveline, it allows us to, again, manage some of the ancillary systems, whether it be electrical alternators, compressors, and now the new IAPUs, the intelligent air processing unit that's in the brake systems. So it gives us a number of opportunities by decoupling from the engine. I mean, when we first introduced hybrid vehicles to the market, it was a bit of a hard sell, to be honest, because bus operators are notoriously conservative when it comes to adopting new technologies. So, however, they did recognize that hybrids, they were going to give low emissions. We could demonstrate that. We were showing at least a 30% reduction in greenhouse gas emissions. So, and therefore, we were improving the CO2 performance and therefore global warming. Also, the NOx and particulates were significantly down and therefore helped with local air quality. But as far as they were concerned, it's all about saving money on fuel, because that money because the hybrid vehicles are quite a bit more expensive than a standard vehicle. And so they need to save that fuel. And in the case of the UK, get grant aid, but through the bus service operators grants, to be able to operate them more effectively. And that all meant that the vehicles pretty much paid for themselves over the cost of a diesel vehicle. The other big advantage, because now we had an electric driveline, is that the vehicle was much quieter. You didn't get the engine revving up and down as much as it used to it does on a standard diesel vehicle. Also, because there's no gearbox, there's no gear changes, and it is very, very smooth and very progressive. And the drivers, as a result of that, really loved it in that they could deliver a drive to their customers, which was so much smoother than the traditional diesel vehicles. And we thought at the time that that adopting hybrids was a more reliable option than using alternative fuels, whether it be biogas, hydrogen, or some other exotic fuel at the time. So, however, as with everything, you don't get anything for nothing, and so there was a bit of added cost and weight as a result of that. Operators were specifically concerned about the technology being quite immature. However, we did put a lot of effort into training the operators, especially with high voltage. This was the first time that bus operators were exposed to high voltage in their bus depots, and they really were quite concerned about that and how they dealt with that. And also battery life, because clearly the battery will only last for a certain period of time. So in the case of the hybrids, we gave them a warranty for 5 years, and pretty much in all cases they lasted that. And then after 5 years, we came up with a deal whereby they could refresh the battery, we'd change out all the modules and give them another 5 years warranty. And we've done that here as well in Hong Kong to ensure that the 6 trial vehicles that are here have still got an effective life in service. So not all hybrids are the same. There are 2 fundamental types. We've got the parallel system at the top there. And in a parallel hybrid system, it maintains the link between the engine and road wheels. So an example of this would be the Volvo B5, for example, in the UK. There's an awful lot of those. But they retain a gearbox, so you don't quite get that same level of smooth operation as you would with the series hybrid, which is underneath it. As you can see there, there is no physical link between the engine and road wheels. That motor is mounted directly through the differential to the road wheels. So in that respect, I really consider that to be an electric vehicle, but in this stage, it's got its own onboard generator, which it needs to be able to operate effectively. So we use the series hybrid system on the Enviro 200 and Enviro 400 in the UK with the BAE Systems hybrid drive. And that proved, as I say, we built about 1,700 of those now in the UK. So let's have a look at some of the key elements. We'll talk about the prime mover in the next slide, but in terms of the electrical machines, on the back of the engine, we've got an integrated starter generator. This is a generator, a permanent magnet machine, that also can be used to start the engine. So in terms of a stop-start variant, we can use that generator to start the engine. And it's amazing when it does. It just clicks in. It's not like a start. It's not like a start where there's no It just goes. It instantly starts when it's being started from that the starter generator. So we've got that, and then attached to the rear axle is a large permanent magnet electric motor, and they have proved to be remarkably efficient over the life of the vehicles. And then the key part is, of course, the battery, the energy storage system. Now, that energy storage system, in the case of these hybrids, is an 11.6 kilowatt-hour battery pack, which today, as we're looking at the EVs with nearly 500 kilowatt-hours of battery, sounds remarkably small. But over 15 years ago, when we first started to introduce those, they were considered to be quite large. So we have the energy storage, and probably the most important thing in the hybrid is how we control the energy in the vehicle, the energy management strategy. That's done by the system control unit, which is the middle unit on the right. And what we have followed is a load following strategy. So often people expect a hybrid vehicle just to sit with the engine at one set RPM point, and then the battery to smooth out the demand. However, it's a perfectly valid strategy. However, it would lead to a very short life of the battery, its battery pack itself. So we used a load following strategy. So as the vehicle pulls away, as well as using battery power, we would lift up the RPM of the engine and generate a bit more electricity as well. And that we found to be the most efficient strategy in operating the hybrid vehicles. So there's a number of different ways of powering your hybrid vehicle, because obviously now you don't necessarily need a big diesel engine. So you've got a few options. Some of you may remember when Park Island over here got a couple of hybrid vehicles in about 2003 or 4. They used a small micro turbine, which is great on emissions. However, they weren't very efficient in terms of fuel consumption, but they were quiet, low power, and one of the big disadvantages, you couldn't power any of the auxiliaries in the normal way. You have to have an electric compressor, an electric power steering system, an electric cooling system, because all of those can't be operated off the micro turbine. Now, quite a few hybrid vehicles in the UK also used a sort of car-derived van type engine, say a 2.5 litre transit type of engine. Now, on paper, it looks great, but what you discover is that those engines end up working incredibly hard in that duty cycle. And whilst they're great in a Ford Transit, in a double-deck bus operating at almost max torque or power almost continuously, it found that they were not particularly good on fuel, and they needed a significant amount of maintenance. But people in bus depots are not used to changing timing belts, for example. And again, they also had the issue with auxiliary drives. And for those reasons, that's why we carried on using a heavy-duty diesel engine, but albeit smaller, as I explained earlier. But that gave a familiarity of the power plant with the operators, and I think that's really quite important, because at the end of the day, if the bus mechanics can't look after them or aren't happy looking after them, the bus just ends up parked on the wall and it never gets used. And we see that the world over. If they're not happy looking after it, it gets ignored by favor of more conventional vehicles. So this is just a little summary of the BAE Systems hybrid drive that we fitted on our hybrid vehicles. Now, I think that the top image on the left there shows how it gave us, as chassis design engineers, the opportunity for the first time of splitting out the drive line. Before, we had to have the drive line all in a line: engine, gearbox, back axle. This, for the first time, meant we didn't have to do that. And so we designed a completely new vehicle, a new vehicle platform around this concept. And that was the Enviro 350 hybrid. And that was a full-size single-decker. We designed it originally for Europe, but also exported it down as places as far as Australia. And it was a really novel way. And it was the first time we were able to split out the driveline like that. So it really gave us an exciting opportunity. And we used a common system, whether we used the smaller on the Enviro 200, the single deckers, where we fitted it on the double deckers, we had the same system. And for the 3-axle vehicles over here, we used a larger hybrid drive system, the HDS 200, which you can see in the middle there. So we'll finish the hybrid section, just having a look at a couple of the examples of hybrid vehicles that we have used over the years. So the top left there, that was the first hybrid vehicle we did. I think Paul Bromley here probably was involved with that when he was head of test and development at Dennis's with me many years ago. So that was a fantastic product, I thought. It was we called it the TMO2. It was the first Enviro 200. It's got a flat floor from the very front to the very back. You can just about make out the back door in that picture. And in that way, we got rid of all that congestion that always used to take place either around the back door or around the front door, because passengers never wanted to be far away from the exit. However, with this layout, passengers were able to get on at the front, all move in one direction, and get off at the back. It was a fantastic concept until Transport for London said, we don't like that anymore, despite them suggesting it in the first place. That's the subject of another lecture. In the middle, we've got the Enviro 400. That was the most popular hybrid that we built. There's probably about, I think I counted up about 1,600 of those at least when I looked earlier today, and they were the backbone of the hybrid fleet. And I'm going to talk a bit more about some of the other hybrid variants of that in a minute. And then on the top right is the Enviro 200. Bottom left was an open top left-hand drive version we did for open top tours. Teamed up with Umvi, a bodybuilder in Europe. And then, of course, to the bottom right is the Australian version. And in the middle at the bottom is the good old hybrid Enviro 500 that we have here in Hong Kong. Okay, so that's enough bus spotting for the time being. And we'll look at some of the other hybrid options that we have implemented. Because we did a mild hybrid. Because the hybrids, they worked, they delivered exactly what they were supposed to do. However, they were expensive. So we were tasked with looking at alternatives to the heavy-duty hybrid drive. And this is a parallel example, a mild diesel hybrid. So what we did is put a smaller motor generator attached to the prop shaft, very small, a small 1 kilowatt-hour ultra capacitor stored on board the vehicle. And you can see in the image there, it's just like a little motor generator that is connected by a belt to the output of the gearbox. And that just recovered enough kinetic energy to meet the regulations of meeting a low carbon emitting bus in the UK. And it still saved about 22% over an equivalent Euro 5. So it delivered excellent air quality performance and again, near zero NOx. That was another diesel hybrid that we used in the UK, and we built about 500 or 600 of those. Another option that was not necessarily as popular or successful, but I think it's just worth mentioning just as not necessarily all hybrid solutions have proved to be a success. We teamed up, I think it was about, it must be 2015, with who was it? GKN, and they had this gyro drive system, which was developed for the Audi Le Mans winning R18 car around that time. So this is a kinetic energy recovery system, but this time they've got you're into the drive line there with that motor generator. The motor generates electricity. The electricity is used to power up a flywheel, and that flywheel that spins at 36,000 up to 36,000 RPM is able to store kinetic energy, which can then be released when the vehicle pulls away again. So it's just another version of a hybrid drive that we have tried and fitted in the UK. However, I will say that none of them lasted that long. What was noticeable is how noisy they were, because the power electronics there and the flywheel itself was sat inside the saloon, and they really were quite noisy, because probably the biggest noise was the vacuum pump necessary to evacuate the flywheel, because that needs to spin in a vacuum. So it was an interesting exercise. Certainly a fair few vehicles were sold with it, but none certainly remain today. But it was an interesting technical exercise. So again, working with BAE Systems, they had an ultra capacitor version of their hybrid drive. I mentioned earlier that one of the challenges of the hybrid was having a battery that had a life of about 5 years, whereas an ultra capacitor has got a much bigger life, and therefore we can BAE used that, and again made even better savings, because the battery, you could really only use the battery within about plus minus 10% of its midpoint, which didn't give you a huge amount of energy you could recover and put back into the system. However, with the ultra capacitor, we were able to capture more energy and then put it back more without having to overstress the battery so much. And this vehicle, because it is a relatively low energy storage system, it wasn't able to have any EV capability. But this was the first vehicle in the UK to achieve the ultra low emitting bus certification standard. So the next one in the series was what was called the electric range hybrid, or the extended range hybrid by some. So this is similar architecture to the first vehicles I've already mentioned, but this time the battery pack has increased in size to 32 kilowatt hours. Now, for me, I think this is a really interesting point, because that 32 kilowatt hour battery fits in virtually the same envelope as the original 11.6 kilowatt hour battery. And a few years on from that now, BAE Systems are looking at a 76 kilowatt hour battery pack that fits again in that same envelope. It's a really nice indication of how battery technology is moving on, how capacity is improving as time goes by. So this bus really is, it is an electric bus, but it still retains the flexibility of having the diesel engine on board, because it can run without having to be charged up at the curbside or an opportunity recharge or back at the depot in the evening. And it can operate for up to about 10 kilometers as a pure electric vehicle. So as well as all the hybrid equipment, you've got electric power steering, we've got electric compressor for the brakes. It's a nice system. So it really is a first step towards pure electric vehicle operation. And we see these, there's a lot of these vehicles now in Ireland, and also running up and down the front in Brighton. It also, as a town planner, it means that you can switch the engine off in designated zones, have a particular low emission zone, switch the engine off at the start if you want to go through, or if you want to, in the case of Australia, for example, you want to go through a bus tunnel, you can just switch the engine off and keep going without having to invest in all the infrastructure you need for a full electric vehicle. So this is yet another really nice little halfway house. So I think this is the last one when it comes to hybrids. This is what we call our virtual electric, which really takes the ER to the next stage, in that this one has opportunity recharge capability. So it's a larger battery pack, 60 kilowatt hours rather than the 11 or the 32 that I've mentioned on previous slides. But it's also got an inductive charging system. We did this, or it must have been about 2014-ish, 2015-ish. From memory. It's around that sort of order of magnitude. So it's quite an early adopter of this technology, certainly in the UK. You can see in the bottom picture there shows an underside view of the chassis. You can just about make out those two round coils. It was GPS based, so we could switch the engine off at certain parts of the drive. Again, it's got a full suite of auxiliaries, so it really is a true electric bus. But it's also got that engine and generator to allow it to have almost infinite range. I mean, we did find it did turn out to be a fairly complex system to put into service. There are vehicles running in Glasgow, and they ran on Route 69 in London. This was actually an interesting exercise, and one of the challenges about opportunity recharge is trying to get permission to sync coils in the road proved, especially in London, to be really difficult. That's why Route 69 was chosen, because Transport for London owned the site at both ends of the routes, and were able eventually to be able to get permission, even on their own sites, to be able to install the infrastructure that was necessary to charge the vehicles. It was a bit complicated. It proved difficult to get the vehicle lined up precisely. And with these early coils, they also had to be lowered from the vehicle to close the gap between the coils and in the road and on the vehicle. So a number of technical challenges, but a really interesting opportunity to demonstrate that a vehicle such as this could operate in London for almost 80% of the time, engine off. And that was the key point of this, key takeaway from this. And also, there's an electric driveline works in London. Right, now that is the end of hybrids, and now we're on to our zero-emission vehicles. He says, just checking the time. Good. So, zero emissions, obviously the panacea of all politicians. It's what we all want. However, there are some significant challenges. I mean, it's easy to build an electric bus. Anybody can do it. We can all do it. However, building an electric bus that meets the requirements of the passengers and the operators is actually really quite difficult. It's our job as a manufacturer is to have the right products, the right total cost of ownership performance, and the right emissions performance at the right price point. And we've got to get all of that right. Otherwise, customers don't want the vehicles. I know we were talking about this earlier. It's easy in somewhere like the UK, where there's significant subsidy for vehicles, for the government to promote clean energy vehicles. Here in Hong Kong, the operators live and die by the fare box. So it is really difficult to incentivize them to move towards full electric vehicles when a passenger isn't going to pay more to get on an electric vehicle or a zero emission vehicle when he can get on a diesel vehicle, which has a significantly lower cost of ownership, certainly at this stage of their life cycle. So we also really do need to take into account the passenger's perspective, and it is down to us to make the vehicle as comfortable and as accommodating as possible. So we'll see, hopefully, how we try to do that on our own electric vehicles. The image is there. We've got the hybrid you've seen already. In the middle is the hydrogen fuel cell demonstrator that's in the UK, the 2-axle vehicle. And on the right is the new 3-axle KMB full electric vehicle that we delivered last week here to Hong Kong. There is more to it than just looking at the curbside emissions, because we talk about zero emissions. It isn't really zero emission, it is zero curbside emissions. We do, as engineers, have to look at well-to-wheel performance of vehicles. It's not, yeah. I mean, here in Hong Kong, I think I was looking it up earlier, our electricity here still comes significantly from fossil fuels. I think between 550 grams per kilowatt hour and 710 grams per kilowatt hour of CO2 is emitted through electricity generation. So it is important to consider that. And also, where do you get your hydrogen from? You've got green hydrogen, you've got brown hydrogen, blue hydrogen. It's almost all the colors of the rainbow hydrogen, but it is important that this really only works if you are getting green hydrogen. Our customers in the UK are struggling to find green hydrogen at the moment without paying about £140 per kilogram. That's an awful lot of money. If you think when a UK bus has got 28 kilograms of hydrogen, £140 each, it's a lot of money. It's a lot of money, especially if you're comparing it with a more traditional driveline. There needs to be some significant incentives to be able to follow that up. Also, we really shouldn't forget that batteries, they don't suddenly appear out of free space. They do take a lot of energy and a lot of valuable resources to be able to create them. And we do need to be able to consider end of life and what we do with those batteries. There's a number of endeavors now. So second life vehicle batteries are reused in power generation, for example, for capture and storage of, say, wind power, for example. So the first life on the vehicle is quite a nasty duty cycle for the vehicle, for the battery. However, second life in a less arduous duty cycle is entirely possible. I also mentioned hydrogen here in terms of where we're getting our hydrogen from, because if we look at round trip efficiency when we are putting hydrogen in a vehicle, in that for hydrogen you need to create it in the first place. Hydrogen doesn't naturally occur. It doesn't suddenly fall into your tanks. You do need to make it. And whether that's through electrolysis of water, that takes quite a significant amount of energy. I think in ballpark terms, around 50 kilowatt hours per kilogram of hydrogen, you need to be able to generate your hydrogen. So if you look on that on the right-hand side there, in terms of round trip efficiency from having electricity in the first place to being able to getting some kinetic energy on the vehicle, with a direct charged EV, we are at about 73%. However, with hydrogen, because you've got to create it, you've got to store it, you've got to liquefy it, you've got to transport it, you've got to compress it, you've got to put it onto the vehicle, there are some significant challenges in there if we're looking at it on a pure energy basis. So I think it is important that we look at the bigger picture. Oops, I've skipped a couple there. So let's have a look at the hydrogen buses now. And there we've got the image of our original vehicle in the UK. So a hydrogen fuel cell vehicle, why hydrogen? And having said what I just said, it does answer some of the questions that we see today in terms of battery electric vehicles around range. Range anxiety is real. It's real here, it's real in the UK. Batteries are getting better, but certainly at this stage, we can get a greater range with a hydrogen vehicle in the UK. With about 300, we can get about 300 miles with a hydrogen vehicle in the UK, which is significantly more than a battery electric vehicle. I mean, especially when you consider things like HVAC, so heating and cooling. We'll talk a bit more about that later, because hotel loads on zero-emission vehicles is an absolutely critical topic for discussion. So, also, hydrogen does win in terms of charge and refuel time. You can fill your hydrogen vehicle in 5 to 15 minutes. However, there is a weight penalty. You can see on the image on the right there some of the hydrogen fuel tanks we fitted on our prototype. Now they are quite heavy, probably not quite as heavy as batteries on an EV, but because we have to store those hydrogen fuel tanks, we do lose a little bit of capacity. And also that shows the challenge over here in Hong Kong with a hydrogen vehicle, where those tanks are currently sitting exactly where we would normally fit the air conditioning system. So we've got a space claim challenge here in Hong Kong. So in the UK, what we're doing, because in the UK, heating is much more important than air conditioning, and we are able to scavenge heat off of the fuel cell to be able to help heat the vehicle, which is good. We'll have a quick look at some of the systems that we're fitting in the hydrogen fuel cell vehicle. So we use the Ballard fuel cell, as I think most people are. It's, they were synonymous really with fuel cells for a very long time. We're using the FC Move 45 kilowatts, the NPROX hydrogen tanks, 28 kilograms of hydrogen. Storing hydrogen on board the vehicle is a challenge. We all know that hydrogen is the smallest element. It has great searching properties. If it can find a way out, it will. The density of hydrogen is about 40 grams per cubic meter, if I remember rightly. It's a very, very light gas, which does mean that if it does leak, it does escape vertically upwards quite quickly, which is a plus point. So in terms of the electric drive itself on the fuel cell electric vehicle, we use the Voith VDS heavy duty system. And what we try and do across all of our designs is to try and maximize commonality as much as possible. So whether it's the fuel cell EV or the battery electric vehicle, we are using the Voith electric drive system. We're using ZF axles throughout, and that gives us commonality with traditional diesel vehicles. We're using a 30 kilowatt hour battery using LTO technology, lithium titanate. Because what we need, this is a hybrid, so what we need is a high power battery, and the lithium titanate chemistry is really good at delivering that. And that'll be a fit and forget. We don't have to change that battery within the life of the vehicle. And I've already mentioned in terms of HVAC is critical on all of these zero emission vehicles. It was the HVAC that killed the hybrid in Hong Kong. It's because we fitted the electric driveline. The electric air conditioning system used so much power. We demonstrated that about 40% of the power is just being used to keep the bus cool, and that is obviously a challenge here as well with our EVs, where we need, especially here in the tropics, where we have such high hotel loads. It's an exciting challenge. But as I said, in the UK, we need heat, not cool. So just got an image here of our design, because again, what I hope you can see here is we've tried to optimize the saloon space for our passengers. No steps, flat floor throughout, seats all the way to the back of the vehicle, and that's most important for us. It's all about delivering a product that we can, passengers can get on with confidence. And I won't go through this in detail, but you can see we put the fuel cell at the back. We've got the hydrogen fuel tanks up the back on this. And obviously the cooling packs and the rest of the equipment is mainly in what used to be the engine bay. And the Voith driveline is sitting pretty much where the old Voith gearbox used to be. And that's just a layout that just shows how it works in the UK. The 11.1 meter vehicle has got 74 seated passengers. The bus is plated though, so in the UK, this is another example of where UK or European legislation differs from Hong Kong, because we're allowed in the UK to get 19.5 tons on 2 axles, whereas here we're only allowed 18 tons, and even that's through exemption. Right, so that's just a quick look at our hybrid vehicles. We'll look now at our battery electric vehicles that we're building now and developed in the UK. So first of all, we'll start with the UK products, where we teamed up with BYD Build Your Dreams. We all know them over in Shenzhen. We've seen their vehicles here. So ADL teamed up with them in 2015 to offer our bodies on the BYD chassis, and that has proven to be a really good partnership. As I say, we've built over 2,000 of these vehicles now, and over 70% now of the UK electric bus market are these vehicles. It's taught us a huge amount about how electric vehicles run and some of the challenges that we see in real life. I've already mentioned HVAC, and I'm going to do it again because it is absolutely critical on the EV vehicles. We've seen, especially this year, with temperatures in Scotland getting down to about -10, the challenges of operating electric vehicles in those climates is proving to use a significant amount of electricity there just to try and keep the vehicles warm, whereas here we have the complete opposite in trying to keep them cool. However, most of the year we can get about 160 miles out of those. What's that? 230 kilometers. So we get a pretty reasonable range in the UK, bearing in mind there's not so much hotel loads as we exhibit here in the tropics. So what are we doing here in Hong Kong that's different? Clearly, UK buses do not work in Hong Kong. We know that. They said they can't cope with the large passenger loads, and we need 3 axles to be able to cope with the vehicle dimension and mass regulations here in Hong Kong, because here we're only allowed 9.5 tons on the drive axle, 7.5 tons on the steer, whereas so that gives you 24 tons for a 3-axle double-decker. The same vehicle in Europe would be allowed to run at 26 tons. So that's extra 2 tons of capacity for exactly the same vehicle would be transformational in terms of capacity. So we do recognize that, I mean, as I mentioned before, the key driver in building an electric double-deck bus for Hong Kong is to build something that is suitable for carrying passengers and not the batteries that power it. That's absolutely critical for us, and hopefully you'll see that we believe we've achieved that in the design that we've come up with. We've preserved the passenger capacity, so it is exactly the same as our current diesel products. There's no compromise in that passenger space. And we've maximized the vehicle range by fitting as many batteries as we humanly possibly can fit in there. There is 472 kilowatt hours of batteries on board that vehicle. Not that one, but the electric version. So it is all about creating a functionally useful double deck as equivalent as possible to the current diesel vehicles so that they fit into the fleet seamlessly. Battery electric bus operation, it is all about energy management. It's a different way of considering purchasing buses now. You no longer just go and buy a vehicle, you put 350 liters of fuel in it and then take it off and away you go. Can't do that anymore. You've really got to think about where you're going to operate that route, especially when, I mean, 472 kilowatt hours of battery sounds an awful lot, but in worst case scenario, with maximum loads on the air conditioning, a full load of passengers, perhaps not the best driver in the world, we can get almost to 3+ kilowatt hours per kilometer, and that is a staggering amount of energy. However, we have to work really carefully to try and minimize that as best as possible. The range is all going to be dependent on seasonality, load on the vehicle, the topography, driver behavior. I mean, we drove the first vehicle over here on Thursday. I mean, it traveled, nearly 300 kilometers and still had about 45% of the battery left. So it all depends on how you use the bus, and you just got to think about that a little bit more when it comes to pure electric vehicles. So we've selected on our vehicles the NMC battery chemistry. I'll come on to battery chemistry in a minute, but we've used that mainly because it delivers the best possible energy density on the vehicle. And it also allows us to optimize the packaging. We've managed to shrink wrap that vehicle around batteries, whether they're under the floor, under the stairs, over the near side front wheel arch, or in the old engine bay. We've managed to fit batteries all the way around the vehicle, and that gives us advantage in terms of spreading the mass around the vehicle as well, because, as I already mentioned, mass distribution is critical in the Hong Kong environment. So what we do now, rather than just as I say, just fill a bus with diesel and off it goes. I think the equivalent of a liter of diesel is about 50 kilowatts, is it, or something like that? It's an amazing amount of energy stored in diesel. So because we only have a limited amount of energy on board, we do have to consider where we're going to operate that bus. So what we do is we data log existing buses in service. We monitor what that bus is doing second by second throughout the day of operation, whether the vehicle is accelerating, how fast it's accelerating, how much energy it's going to use to keep the vehicle cool, how much energy is going into the brakes, how much could be recovered through it, regenerative braking. And then we map that out over the course of a couple of weeks and then integrate that over the time and work out whether an electric vehicle would operate suitably on that particular route and advise accordingly. Another thing about energy, if you look at that bar graph there, which logs, I think it's route 2A on that one, you'll see that the HVAC is a very large peak, even larger than the driveline, because the driveline, remember, you're getting back regenerative brake energy as it cools, but the HVAC has been incredibly significant in terms of the range for this vehicle. So bus operators, for example, they're used to setting the air conditioning here at 22.5 degrees and having the passengers shiver on the top deck of the vehicle as they go to work. This is an opportunity to change that mold. We could just setting the temperature up by a couple of degrees will increase the range of the vehicle significantly. Now's an opportunity to start looking at that as a wider issue in terms of vehicle operation. But actually doing this energy analysis and understanding how the buses will use energy is absolutely critical to deliver something to the customers that they can use practically in service. I mentioned battery technology earlier, and there is a trade-off with different battery technologies. We've used NMC, which is the lithium manganese cobalt oxide battery, just simply because of its very high specific energy and energy density, and that allows us to carry much more energy in a smaller space, and we considered that to be the best possible approach for a vehicle where energy management is critical, especially out here in Hong Kong. So we talked earlier about the difference between a power battery and an energy battery, and the NMC batteries can be tuned for both power and energy, and obviously we use an energy battery for the full electric vehicles. But we do recognize that LFP is a very popular battery pack here in China, but we have gone for the higher energy density of NMC. But so what have we done with these batteries? I mentioned earlier we have pretty much shrunk wrapped those around the vehicle. We've got 5 battery packs under the floor. We've got 3 underneath the staircase and over the wheel arch, and 6 more in the back end. And each one of those, there's 4 strings there, 2 in the back, 1 at the front, and 1 under the floor. Each of those strings has got 118 kilowatts each, and each together that comes up to 472 kilowatt hours of gross capacity. 472 kilowatt hours. This is an electric bus. That's a headline number. You can't use 472 kilowatt hours, and you never will do. You're only able to, at best, absolute best, you'll be able to use 90%. So you don't run the thing to 0 and then fill it up to 100. That would just destroy the battery in a relatively short space of time. It's all about battery management, getting the most out of that battery asset. So in terms of our range calculations, we usually use about 80%. And then because we know the bus is going to be operated for about 10 years with that set of batteries, maybe, after those 10 years, the batteries will degrade by a certain amount. Say, if we say it's 80%, so at the beginning of life, we say that battery has got that vehicle will have a range of 80% of 80%. So it won't be 472 kilowatt hours. We do our beginning of life calculation based on about 330 kilowatt hours. And that way we know that in 10 years time, that bus is still going to have that same range that we promise on day one, even though we know on day one, it will have a significantly higher range than that, theoretically. So, I mean, that's an important point. I mean, headline figures on day one, so easy to quote, but we've got to think about the full life of that battery pack, not just day one. And I think that is critical. So this is what we've achieved on the Enviro 500 EV for Hong Kong. This is, and if you looked at that, you would not see the difference between a standard diesel vehicle. When I showed it off for the first time on Saturday, as I say, at KMB's 90th anniversary celebrations, if you step on it as a passenger, you pretty much wouldn't know that that was an electric bus because all the batteries are hidden outside of the passenger compartment. There's no reduction of seats in that vehicle. There are 82 seats, and the only reason there's less than a standard diesel vehicle is because there's 2 wheelchair spaces, and KMB took the conscious decision to spread the seats out upstairs to deliver a better passenger experience for their customers. So in theory, we can still get 90 passengers on that vehicle, which is a staggering number of passengers, along with probably about, we'll find out when it is formally weighed by the Transport Department. We're expecting about 125 passengers overall. And that's another 30 to 40 standees, depending on the layout in the lower saloon. So we are really pleased and proud about how we've managed to shrink wrap that vehicle around that battery pack. And again, the key systems that are on that bus are as common as possible with the rest of the product range. Now that delivers not only efficiency, that's efficiency for the operators because because the operators' mechanics are familiar with many of the systems, they're familiar with the axles, all those axles are the same. That's one of the reasons we decided to go with the Voith VEDS driveline system. It wasn't just because it is one of the most efficient drive motors on the market. It was because we could use the same AV133 drive axle as a standard diesel vehicle, which everybody is familiar with, and with the they potentially would have difficulty in looking after hub motors, for example. So we decided to go with the traction motor option, and that's the same traction motor we use on the hydrogen vehicles as well as the rest of our zero-emission vehicle range. We've used the NMC battery, as I say. We've used this it's got a specific energy of greater than 185 watt-hours per kilogram, and that's today. That's only going to improve. We're expecting to see the next step change in battery energy density in the next 3 years, and then come 2028, as potentially solid-state batteries become more commercially available, then I think we'll start seeing some significantly improved energy density, such that maybe the hydrogen versus battery electric vehicle debate is not quite so pronounced as it is today. So, in terms of heating and ventilation, we've got a fully electric heat pump, and there is an option there for reheat. So some of the operators here in Hong Kong do like to have a reheat system to keep people warm in winter as well as cool in summer. And also for efficiency, we have integrated that with the BTMS, that's the battery thermal management system, because clearly thermal management of the battery is absolutely critical to deliver a good life for the batteries because they don't like getting hot, and also support higher rates of charging. And because it's an Alexander Dennis vehicle, we've used a lightweight aluminium, and we've used a lot more composite in this to try and reduce the weight. So it's now got a composite roof, it's got a composite interdeck as well, and we've managed to minimize the weight as a result of that. Even so, because the batteries have a mass of roughly just over 2.5 tons. So even if you consider taking out an engine, a gearbox, and some of the ancillaries around that, we've still seen an increase in unladen mass. And that's why we can't quite fill the vehicle up with standees as we would have done in the past with the diesel vehicle. So there it is. That is the Enviro 500 EV that I hope you will all get an opportunity to see fairly soon here in Hong Kong. That's the first one, just before it left the factory last Thursday. So it is something we are really proud of. I had a chance to drive it around in China a couple of weeks ago, and it's an absolute delight to drive. It's just like driving a hybrid, but with no diesel engine. So it's yeah, we're really proud about how that's working. And we can't talk about electric vehicles without mentioning charging and the infrastructure needed to be able to support the charging. Because whether it's a hydrogen vehicle or it's an electric vehicle, we are going to need to invest in some kind of infrastructure. When Transport for London installed their first 5 hydrogen vehicles in London, they had to build a dedicated workshop for it, which had hydrogen sensors in the roof, blowout panels in the side of it, and they had to jump through an enormous number of hoops to be able to operate those vehicles in service. So there are some challenges around that. And we know that the Transport Department here are having a lot of discussions with various vehicle manufacturers to try and allow hydrogen vehicles to operate here. But also, when it comes to battery vehicles as well, you need a significant amount of infrastructure in terms of charging infrastructure in the depot. If we look at some of the depots that KMB have, where you've got 700 or 800 buses running out of one depot, that's an awful lot of electricity that needs to go to that depot at any one time. And you do need a lot of support from infrastructure companies. We see that around the world wherever we've introduced electric vehicles. I mean, take New Zealand, for example. They're obviously struggling at the moment after the floods over Christmas, and trying to get enough electricity off the grid into their depots is proving to be a significant challenge. And I mean, also opportunity charging is available, and that's a good way of getting a lot of power into a vehicle quite quickly. And we're offering opportunity charge on our vehicles now in the UK, as well as potentially out here if there's demand for it as well. But being able to manage your battery charging is also important, because you've got an awful lot of vehicles that could potentially suddenly demand an awful lot of charge at exactly the same time. And there's a lot of clever software available now, and we work with a lot of partners who can spread the load. So the driver would just drive the bus back at the end of the day, he'll park it up, leave the bus, and then that bus would then automatically charge at the optimum time of the evening to spread the load out throughout the depot. And there's a lot of good things that can be done with that, and we work with a lot of partners to make that happen. There was a lot of debate in the early days about charging of electric vehicles over whether AC charging, DC charging, which standards. But it does seem now that most bus operators are choosing CCS2, the DC charging. AC was great at the beginning because it was cheap. However, for us, it meant we obviously have to put the rectification on board the vehicle, because you're taking AC on. Your batteries are obviously charged with DC, so you're just moving the equipment from the charger into the vehicle. So I'd much rather have that equipment stationary in the depot rather than being carried around all day and using up our valuable energy. So DC seems to be the way forward now, CCS2, as I say. And I've already mentioned the charge management being absolutely critical. And I'm just going to finish with a really good example, I think, of how we have implemented or worked with a customer to implement. This was the first full electric bus depot in London. This is Waterloo Garage. It is just around the corner from Waterloo Station. You can see from that aerial photograph, it is in a very highly populated residential area, and electrifying the fleet has actually delivered a number of opportunities for the operator, because previously they couldn't operate out of there at the weekends, but now there's no noise because the vehicles are all electrically charged. They can now use those vehicles at other times as well, whereas previously they were prohibited to do so. I think the challenge you can see there in the top right is the layout, because there were 46 buses in that picture, and 43 of them can be charged at any one time overnight. And that's one of the big differences in terms of the electric vehicles. You do have to think a bit more about your depot layout and how you're able to charge those vehicles. So we're pretty much coming up to time. So I am going to just summarize really that, I mean, I've mentioned both our hydrogen vehicles and our electrical vehicles. It isn't going to be one or the other. It may well be both. At the moment, I mean, the hydrogen vehicles win in terms of the greater daily range at the moment. Although, doing some research over here in Hong Kong, if you look at the number of routes, number of daily routes that can operate at under 200 kilometers, there's probably about 1,000 of the buses already can operate under 200 kilometers a day. So the key to this is putting EVs into service on those routes first. Nobody in their right mind is going to put an electric vehicle on, say, one of the Airbus routes out to the airport. They do 600 odd kilometers every day, and they almost run out of diesel doing that, 350 liters of diesel. That's the equivalent of over 1,000 kilowatt hours of electricity if we convert it. So it's, you're not going to do it there, but you're going to pick your battles at first and select optimum routes to be able to demonstrate the vehicles first. And I think that's a really exciting opportunity we've got to work with the operators and the government here as well. So in terms of higher passenger capacity, I've already mentioned the mass of the vehicles, batteries. So here in Hong Kong, you can potentially have more standees on a hydrogen vehicle. But I guess we'll wait and see until when the first one's certified here. But hydrogen storage takes less physical space in theory. However, we've seen we've managed to capture as much space as possible on our EV, so we don't lose any passengers over diesel. In terms of the simple fueling structure, I mean, we could argue that the battery electric vehicles are easier to charge rather than set up a hydrogen fuel filling station. We've seen in the UK there's been significant difficulties some of our customers are having obtaining hydrogen and running hydrogen vehicles, to the extent that we are seeing a move at the moment away from hydrogen and more to battery electric vehicles. People who have tried hydrogen and now consider it to be an interesting experiment and moving back to EVs now. And in terms of total cost of ownership, we do believe that the battery electric vehicle is lower because of the costs of hydrogen. Hydrogen is really expensive at the moment. Also higher maintenance costs. I mean, the fuel cells, they're not fit and forget. The membrane within will need some degree of maintenance every 2 to 3 years, depending on the system and the cleanliness of the hydrogen that you're using. And all of this, though, can improve with volume. I think we are on the cusp of a really exciting journey in terms of vehicle transitions, especially here in Hong Kong, where we have, I think, one of the very best public transport bus networks in the world. You've got about 4 million passenger journeys here in Hong Kong, and if we can translate some of those into electric, whether it's fuel cell or battery electric vehicles, that'll be transformational for not only the customers, the operators, but also Hong Kong itself. So I'm going to finish with this picture because I think this is a picture from my office, actually, in Kowloon Bay. Yeah, I see Kenneth there, who works for us, recognizes it instantly. His desk backs onto this. So this is the view on Kowloon Bay Bus Depot. There's about 250 odd buses. I've counted them. There's about 250 buses on the top floor alone, and they look like, I call that an image of bus Tetris. And I just think it demonstrates one of the challenges we have here in electrifying the fleet, or turning the fleet from diesel, which you can fill in 60 to 90 seconds, 2 rows, say 16 buses at a time, 90 seconds. You can run 1,000 buses in overnight, just going through the fueling bay, and translating that into plugging that lot in either to a hydrogen filling station for a significant number of minutes, or into a battery charging point. So I'll finish with that slide and say thank you very much for listening. It's been great to be able to talk to you all today here in person in the university, and also to all of you online who I can't see. So thank you very much indeed, and I'll be very happy to take some questions now. Thank you.
Thank you very much, Andy. May I ask Andy to move along or to speak on this microphone? And we are actually suffering a heavy problem over time due to the great nutrients of the presentation. But let's squeeze some little bit time on question and answer. Shall we have 2 questions maximum on the floor, and 1 or maximum 2 questions online? So if I may pass over the microphone to Tracy, my helper.
Hello, Andy. And I would like to ask the first question. And do you have a vision about the future bus operation in Hong Kong? You know, it seems to me, you know, say these electric buses, hydrogen buses, fuel cell buses, you know, and they are just for trial, and never could expand. You know, the number could never can never be expanded in Hong Kong. And I just returned from the UK. I saw many hybrid buses, electric buses, you know, in operation in London. And do you have a vision yourself? And say in 5 years, do you see any, say, significant expansion of these environmentally friendly buses? And then my second question, you know, you have as the managing director, do you have a strategy to sell these electric buses and hybrid buses, you know, and hydrogen fuel cell buses in Hong Kong? I'm sure, you know, there are quite a lot of obstacles. How are you going to overcome these obstacles, you know, in order for you as the managing director of Alexander Dennis, you know, to sell these buses in Hong Kong? Thank you.
Thank you. Hopefully you still hear me. Okay, so there's two questions. This one here. How's that? Okay. Right. Hopefully you can all hear me. So I'll ask the first part first because I recognize that the UK is a significantly different market to Hong Kong. I mentioned earlier the low carbon emitting bus scheme, the green bus scheme, green bus fund in the UK, which subsidised the difference in value between a diesel vehicle and a low carbon emitting bus. The difference between the price was subsidised by the government for some significant tranches of vehicles. So that worked outside of London. Now, London is a special case because the operators there are operating, they're just running the service on behalf of Transport for London. It's Transport for London who, in effect, fund the vehicles through the tendering process. They will mandate the vehicle type, and therefore the contract will have a price that reflects the type of vehicle that Transport for London are demanding. And Transport for London demanded some time ago that all new buses would be either hybrid or electric. All new single-deckers will be electric, and now all new double-deckers are going to be electric. And they can mandate that through the tendering process. Here in Hong Kong is significantly different. The operators live and die by the fare box. And as I mentioned earlier, at the moment, all the operators are doing is by buying vehicles for replacement. Now, it's lucky, really, because at the moment, the Hong Kong market is entirely predictable. Every bus has got a life of 18 years. And so 18 years ago, there was a big lull in the market, which is just a cyclical from when China Motor Bus failed and then and was taken over by New World and the City Bus came into the market. So we're just on that at that point in the cycle where it's not that many vehicles are needed at the moment. So K&B have taken the plunge. They have bought 52 full electric 3-axle double-deckers already. And you're going to start seeing those going into service. But really, as it stands today, it is down to the operators to spend more money on buses. And unless they can see an increase through the fare box, the impetus to do it, I can't really see it happening and taking off quickly unless there is some kind of either subsidy or fare opportunity for fare increases through decarbonisation of the fleet. Is that okay for the first part? And the second part was, how am I going to sell them? I think probably I can best summarize it by using the word magic. But no, returning, but I jest. No, I mean, it is a challenge under those circumstances because the operators here, whereas in the UK, they are looking for a certain emission technology for their vehicles. Here, the operators are looking for a value. And that value at the moment, when it is significantly more expensive than a diesel, is very hard. So what we have done is we have built those first vehicles. We've got those first vehicles here in Hong Kong, and we're going to promote those vehicles as being zero emissions and demonstrate that it is possible to deliver a full electric bus, and then work closely with the customers to try and minimize the cost of ownership. Because an electric bus, you've taken out the engine, you've taken out the gearbox. There are significant maintenance items that you will not have to look after for the life of that vehicle. So you're making some savings there. The cost of electricity here is quite cheap. Cost of fuel is relatively expensive. There's savings to be made there. So there is an argument in terms of total cost of ownership that electric long-term is going to deliver a significant saving. But at the moment, all operators around the world are in sort of a let's wait and see what everybody else does sort of state, rather than jumping in with both feet, especially if you live and die by the fare box. Sorry, that was a very long-winded way of saying we're going to sell as many as possible. And I'm giving discounts today, actually, if anybody wants to shake my hand. Right, so
Thank you, Andy, for a very insightful talk. Actually, I might be wrong. From many of the talks about hydrogen buses, they seem to just focus on the fuel cell type, rather than the hydrogen engine buses. So why is that the case? And what are the relative merits between the hydrogen engine bus and the hydrogen fuel cell buses? And also a second question to follow. Now a few years ago, we are talking about carbon dioxide capture all the time, but suddenly we switch completely almost to hydrogen economy. Well, in the future, there are so many work been going on for the last 10 or 20 years for carbon dioxide capture. I think it will work, for the fossil power stations and also for our diesel engines and gasoline engines as well, right? So do you envisage that technology will come back to be retrofitted on our buses so that we can use diesel fuels, fossil fuels as before? The last question is that on your charging of the battery, the NNC battery, do you generate hydrogen?
I'll answer the last one first, because I don't believe we do. It's the first time I've been asked that question. I don't think we do, because I think they were pretty much a sealed unit. So I don't think so. But I'm going to find out tomorrow, though. Oh, yes. No, it doesn't work like that. No, it doesn't work like that. So the next one was hydrogen. Actually, you made a good point, and I did have it in my notes that I didn't look at, which was the about hydrogen engines. So yes, it's entirely possible. Certainly, our favoured engine manufacturer is promoting hydrogen fuel engines now for delivery in the next few years. It is entirely possible. There is a challenge, though, in terms of internal combustion engines with hydrogen, in that it isn't just pure water that's going to come out of them, because if you remember, you get NOx production within an internal combustion engine at high temperature and pressure. So within a hydrogen engine, you will still get some NOx production. To what extent? The engine manufacturers haven't been able to answer that question precisely yet, but they believe they will be able to meet Euro 7 regulations easily with a hydrogen internal combustion engine. So yes, it's possible. However, you are putting some more complexity in that you're putting the engine and gearbox back in, as well as all of the hydrogen fuel tanks. So over here, you probably need to get best part of 50 kilograms of hydrogen in the back of the vehicle, which is quite a significant space claim. So you probably will be sacrificing some kind of passenger space. So yes, possible, but yes, no, that's true. No, that's a very good point. Yeah, no, you can burn it, and it isn't quite as critical. You won't poison the catalyst, so you're right. Yeah, it's certainly an option. It isn't one. It's one that's sort of in our radar, but not. But it's in a little bit further out. And I'll finish the last one. Carbon dioxide capture and storage, CCS, isn't it? To be honest, I'm not overly familiar with where we are with CCS. I can't imagine how you could operate a system on the back of a bus to stop the combustion products being stored, because I mean that's an enormous volume that you would have to store in a fairly somehow. I can imagine it working with some kind of offset scheme, but not on vehicle. Does that make sense? Yeah. Again, well done. You've answered me yet another question that I've never been asked before.
So there are, sorry. So there are so many questions from the WebEx. Fortunately, we're running out of time, so I will just draw two of them. So, of course, first one is about the fire load. So one of the members are asking that one of the challenges in road infrastructures, especially tunnels, is the fire load of electric vehicles when they catch fire. Would the fire load of an electric E500 remain the same as a diesel E500?
So do you say you have a firewall? So the barrier between the batteries and the saloon? Firewall.
Yeah.
So yeah, so the passenger space is well insulated from the batteries. The underfloor batteries, they are encased in a half mil of stainless steel. The battery, each individual battery pack has got a blowout disc, which will vent any, in the unlikely event of a thermal runaway, it'll vent any combustion gases away from the vehicle and away from the battery. There is a stainless steel firewall between the engine bay, what used to be the engine bay, where the majority of the batteries are, and the front of the vehicle. And there's also individual firewalls over the wheel arches and underneath the staircase as well. So each area has got multiple levels of protection. As well as in the first cases, the first defense is the battery thermal management system and the battery management system itself, which is all designed to fail safe under ECE Reg 100.02, I think it is. There is a requirement that the vehicle can predict thermal runaway to allow a 5-minute warning of any potential issue, which means the driver has plenty of time to be able to make it safe in an emergency and evacuate the vehicle safely.
The final question is, which option is the best to apply here in HK? Hydrogen, NOx, hybrid before 2035. Is that important to offer incentives by government?
Sorry, can you just say it once more time?
I think our members is saying the hydrogen, NOx, and the hybrid solution of the bus. Which one before? Because we have some policy for providing green energies. So before 2035, what do you think is the best option to apply suitable to our bus in Hong Kong?
I feel, yeah, I've already mentioned that obviously the operators live and die by the fare box, so that is their only source of income. If you wish to accelerate the program, then I think some kind of subsidy would be, whether it's through the EPD or some other kind of subsidy, as has been the case almost everywhere else in the world. That would be the gateway to earlier adoption of EVs, definitely, whether it's hydrogen, a battery electric vehicle, or any other technology. I can see that some kind of subsidy will always help, and try and just get over that initial hump, the initial nervousness that operators have of trying a new technology en masse. Does that answer it, do you think?
Yes, thank you so much.
Okay, thanks a lot.
For today.
They weren't too hard.
So technical.
Running short. If I may, let us adjourn the question and answer session on the floor right now. And anybody on the floor now can grab Andy after the formal session and ask as many questions as you like, as long as he please.
Only if they can run faster than I can.
But by all means, as formality, have a certificate of appreciation. And our chairman, engineer, Fan Chan, on behalf of Felicia Learn, representing, to present this appreciation certificate to you. So, Alexander, you have a final remark to address our participants, both online and physically here.
Actually, we have about 40, 50 people here. But actually, there are more than 400 registered for attending this webinar online. And unfortunately, we don't have the time to entertain so many questions from people attending online. And anyway, it is a very good seminar. Thank you very much, Andy. Thank you.
So, ladies and gentlemen, may I adjourn the seminar at this particular point in time? Those who attend physically, when you leave the venue, don't forget to ensure you scan that QR code on the wall to register the attendance in order to receive your copy of certificate of attendance. And for those online, also thank you for coming, and I encourage you to come physically in Hong Kong in next seminar. Hong Kong has returned all normal. Thank you very much. Good evening. I thought I got it. Yeah, I said it got 8 minutes. It's spot on. It's spot on. So you and this is the questions from you. Yeah, 25 years.